we all good? Yeah? Okay, sweet. Um, if you, what are we doing? I don't know. I don't actually know how many. We're doing something tonight. What are we doing? Well, let me open up my. It was a good. Give me a second, because I'm opening up a thing for learning Rust, because I'm still learning it. Oh, and if you have questions, oh shit. Whoa, we okay? Yes, we're okay. Maybe. Fuck. Are we just having a stroke now? Ah, no, no me gusta. Is it just a crashing? Do I have to stoop? Ah, fuck. Yeah, okay, give me a sec. I'm gonna have to stop and resume the stream. I'll be right back. Give me a second. Oh, shit. Good, verdammt. Okay. 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 So, are we all good? Are we good in the hood? We okay? Maybe? Yes? No? God, what the flimp florp is going on? Are we dead now? Is this the, oh, are we, okay, I'm gonna operate under the idea that everything's okay and that everything's working. Hopefully, we won't have to deal with that again. Anyways, so I'm gonna say, so yeah. Oh, fucking gross emojis. Ew. So yeah, if you have any questions, don't forget to ask them, I guess. Don't be afraid to. I'm going to be playing music in the background. If it's too loud, tell me. And I will be more than happy to adjust it. So I have this up, and so this, I'm going to be using this for learning Rust. And then I'm going to open up this. Yes. Okay. Okay, so all that loading up. Come on, Emacs. Okay. Okay. We're all good. So, I might actually just pause the music. I'm gonna get distracted. Let's look at some Rust. So, real quick, comments, are preceded by forward slashes. So it's basically the same as, the hash symbol in Python, except, instead of a hash symbol, you put, forward slashes. So, this won't do anything. And you know how you can have basically multi-line comments in Python by having like 3 strings or 3 quotation marks like this, and then you can have stuff like that. Well, if you wanted to do that in Rust, you would have a forward slash followed by an asterisk, by a star symbol, and then to end it, star symbol, forward slash, right? So multi-line comment, right? Hopefully that makes sense. So let's make hello world program. So in Python, I'm gonna write it in a comment, but as a Python program. So the Python program would look something like this. And I'm gonna do second for a hot second. Okay, we're good? Yeah, good in the hood, yeah. So anyways, so that's what the Hello World program might look like in Python. Honestly, you could just omit this and it would be perfectly fine, but to make it more similar, I'm going to write it like this. So, so the Hello World program in Rust looks like this. fn main. Okay, now let's real quick talk about some of the similarities and differences. Real quick. So in Python, the way that it, give me a second, I want to open up a soda because I'm an awful person. But so in Python, the way that it figures out what code is a part of what statement, right? Like that this line to print out hello world is a part of this function is by the level of indentation, right? How many tabs or spaces you have before the command. But for Rust, which is a C-like programming language, it figures that out by these curly braces, right? So this function will need something in curly braces, which is some code to execute, right? So the thing in the curly braces, in this case, is the single statement that prints out hello world. And you can see it looks pretty similar. One of the other differences is that I have to end most of my statements off with semicolons in Rust. So I can, another thing is that this is a properly compiled language. You can argue that, and I mean it would be it would be a valid argument to say that Python is also compiled. But the difference is that Python at the end of the day gets interpreted, whereas a Rust program gets compiled to binary on my computer, and then my computer runs it. Anyhow, so I'm gonna compile this, or actually I can do a cargo run. Yeah, so I'm gonna run my program, so it's gonna first compile it and then run it. So we should see down here that it says hello world. Please hold. Oh, Jesus, it was there for just a second, just as okay, here we go. So you can see that, gosh dang. So you can see that there's some information. It says that we're running the program. And then if we look at it, we have this, had the text there. So if I type in learning.exe, I should run it and it should just type out hello world or not, whatever suits your fancy. Now would it be main.exe? Nope. Incorrect. Yikes, where is it? I can't see it. I guess I am sad. Nope. Never mind. Oh well. So I guess if I really wanted to, I could just go rust c. Okay, so yeah, here we go. So you can see I compiled it, and then when I ran it, it's hello world. So it's working. Anyways, so that's pretty sweet, right? I mean, that's pretty similar to Python, I guess. But there's a big difference. So let us look at variables real quick. Say in Python I had something like x equals 5, right? I could then have something like print x times 2 is equal to x times 2. I'm going to try to keep it similar to Python for a little bit, and then I'm going to make it look real different. Well, I'm going to show you how it's different more. So in Python, when you make a variable, you just type in the name of your variable and then the equal sign and then the value that you want to give to your variable. It's a little different in Rust, and I can show you some of the ways that it's different. So first off, you'll type in the keyword let to say that you are making a variable. Next, you're going to have your variables, in this case x, an equal sign, and then 5. So this looks pretty similar already to the Python code, right? Except, there's this let keyword. But you can make it a little more different. So at compile time, so real quick, a compiler, what's a compiler? A compiler is basically a translator for your Rust program, and it'll translate it into binary that your computer can understand and execute. So at compile time, while this is being translated, it doesn't actually know what value is stored in X, right? But it can figure it out or infer it by 5, right? Because 5 has to be an integer because there's no floating point. There's no decimal portion to it. It's just a full number. Therefore, it has to be some sort of integer. So what we're going to do now, print ln, we're going to say x times 2 is equal to, and then what we're going to do is we're going to do the, I think it's this, and then comma x. So this line is a little different. You can see these curly braces in the string. In this case, this says that we're going to take some information and basically stick it into the string as text. So we're going to say we're going to substitute, or we're going to put in the value of x into the string. So what we should get out is x times 2, oh, sugar. Give me some, okay. Okay, what we're going to do is it's going to be x times 2, and then the value that we're putting in is the result of multiplying x by 2, right? I know how to code. Anyhow, so if we run this, we should see x times 2 is equal to 10. And you can see down here, x times 2 is equal to 10. I don't know if you can see that. Maybe that's not super visible. So what I'll do is I'll add 2 new lines, and then I'll run it again. So it should, yeah. I think that looks better. Because I'm watching back the stream while I go on, so yeah, I mean, I think so. Here, I'll just do something real quick. Give me a hot sec. ln 1, 2, 3, 4, 5. I'll just do this to make it. I mean, oh, okay. So it looks like it's okay in the stream, but this will just make it better. So there we go. You can see it says x times 2 is equal to 10, which means in this case, x has to be 5. So that's pretty neat. I mean, that's looks fairly similar to Python. But so in Python, after I have this print statement, I could say x is equal to 10 afterwards, and I could do something different. And Python would be very fine with that. So I could say, I could change it to 10, and then I could just do that statement again. In this case, instead of it being 10, it would be 20, right? So let's see if we can do that in Rust. I mean, I know the answer to it, but this is to illustrate the difference. Okay, so we have x set to 5. We do this, so we should get 10 out. Then we set x to 10, and we do the same thing, and we expect to get 20. What we're going to get instead is an error. So let's run that. Oh shit. Never mind. That's confusing. I'm confused by that. That ain't right. What if because it shouldn't let you do that. Usually it should scream at you. I want you to scream at me, damn it. What's the hiccup in the video? Because this is the same thing that I'm working with, right? Yeah. So really? Huh. Okay, never mind. Anyways, well, what I was expecting to show you is that when you make a variable in Rust, it's usually when you first define it, it defines it as being immutable. What does that mean? Immutable means it can't change. So what I expected to happen is after I set this to 5, that when I tried to set it to 10, it would freak out at me and scream and shout and be very unhappy with me. Instead, I was surprised to see that it is mutable. I don't know why. Oh, I know why. Okay, let's forget that never happened, right? So what we're gonna do is, because we're not redefining it, we've already have the variable defined here, so we don't need the let command again. We can just say, oh, x is equal to 10. So forget the thing that just happened. Okay, so now if I run it, this is what I expected. Now that I run it, it raises an error. And so if we look through this error, it says the error is on line 12, right when, or line 15 rather, when we set x equal to 10. And it says it cannot assign twice to an immutable variable. So now I can properly talk about the thing I was meaning. God, that threw me for a loop. Excuse me. So what's going on? So when immutable means it's not mutable. Mutable means it can change. So immutable means it cannot change. So when you make a variable, by default, you can't change the value again. You know, you can't change it like this, right? Excuse me. So how do you have mutable values so it's like Python, right? Because there might be an instance where I want to change the value of x, right? Like this. The way you do that is when you're defining your variable up here, x equals 5, right before the name of your variable, you're going to have another keyword, which is going to be mut or mut. So let mut x. This mut or mut keyword says that this value is mutable, it can change. So if I save that and I run it again, we should get no errors. And you can see that we successfully changed x to 5 and to 10. Sweet. Neato. So there's a difference between Python and stuff. But also, there may be instances, so since it's compiled, although some values can be inferred by, you know, what you're assigning it to, excuse me, there are some instances in which you have to explicitly say what type of value you're dealing with. Now, the way that you explicitly say what value you're using is in a variable declaration, that is, after the name of your variable, you're going to have a colon and then the type of your value. So for example, 5, it's an integer, but I'm going to say that 5 is going to be stored as a 32-bit integer. What's a 32-bit integer real quick? It's a number represented with 32 digits, basically. So we would expect like something like 30-ish 30-ish zeros followed by 5 in binary, right? Anyways, so if I run this, this should be, we shouldn't get an error, right? Because 5 is an integer. I said it's an integer, right? I'm just saying stuff that can be inferred. If we run that and we see we get no errors, but we can make it have an error. So if I forced it to be an error, like I said, that this was really bool, yeah. So if I said that 5 is a boolean, a false or a true value, this should give me an error probably, right? Because 5 is an integer, it's not a boolean. That makes no sense. And we see we get an error. Expected a boolean, found an integral variable, found an integer. Yeah, so it makes no sense. Oh shit. Oh no. Oh no. Disregard that. Anyhow, so there's that. So that's pretty sweet. That's variables. So if you want to be able to just change the value that you're dealing with on the fly, you have to set it as mutable. Okay. Sweet. Okay. So now let us look through some example of little things, right? How do you guys feel about FizzBuzz? There's like one person watching. I don't know if I'm just by my lonesome, but if there's someone else here, like actually here, tell me, what do you think of programming a little FizzBuzz thing to show off for loops and while loops? In the meantime, I will unpause music. No. It's good one. Okay, I'm just gonna do it. I'm gonna do both. So what I'm gonna do is, so we're gonna go through the numbers 1 through 30. So we're gonna say our number, n, is mutable. It is, well, it's a number, an integer, and I'm gonna set it to 1. So we're gonna have a while loop. Let me turn that down. But so what our while loop, gosh dang it. Anyways, so our while loop, we're just going to set it up so we go through all the numbers from 1 to 30. Yeah. So while, and then n is less than or equal to 30. Then we're going to do some stuff in these curly braces. And you can already see this looks pretty similar to Python, right? The difference being, again, we use semicolons and we have these curly braces. And I mean, and some other things too, but in terms of the while loop structure. So we're going to have an if statement. So if our number mod 15 equals 0, so it's divisible by 3 and 5, we're going to print out FizzBuzz. else if, this is different than elif, it's just else and then if. Else if n is divisible by 3, we're going to print fizz, oh, sugar, fizz, else if our number is divisible by 5 instead, we're going to print, gosh, we're going to print buzz, and then finally, otherwise, it's not divisible by any of those numbers, we're just going to print out the number. Then after we're done with all of that code, we're going to add 1 to n. So we should go through all the numbers between 1 to 30. And I'm gonna remove that. Okay, so let's run this. Okay. we go down here, we have 1, 2, 3, divisible by 3, 4, 5, divisible by 5, 6, divisible by 3, 7, 8, 9, 3, no, 3, 5, 12, which is 3, 14, 15, FizzBuzz. So yeah, and we should get FizzBuzz again at 3. So look at that. I mean, it's not that different from what I probably would have written in Python, honestly. I mean, I'll be honest, there's a little bit of a difference on how the mod and division operators work. So if I did 10 divided by 5, no, if I did 12 divided by 5, right, that would be, what is that, let's say 10.1 or something like that, right? You would have 2 point something or other, right? But in Python you would expect that, but in Rust you would actually get just 2. And if you wanted that something or other, you would have to do 12 mod 5. I mean, but that's if you're dealing with integers, would you not get the remainder when dividing? If I did 12.0 and divided by 5.0 or something, I would get 2 point something or other. Just to clean that up. Okay, so now let's just change this so we use a for loop. So what we're gonna do is I'm gonna just change that. Oh, and I need to remove this. So for our number n in the numbers between 1 to 30, this should be exactly the same as before. Exclusive range. Oh, okay. One thing I can say that I really like about Rust is that the compiler is really smart. So it can tell you most of the time, like I think like every time that I've used it, like exactly what your error is. So anyways, this is an inclusive range. So I'm saying I want to go from 1 up to 30, including 30. So this should be exactly the same as before with the while loop. So yeah, we got 1 FizzBuzz and we got 2 FizzBuzz, right? So it worked. Exactly the same. pretty neat, if I have to say so myself. I mean, again, it's interesting. So let me show you functions, eh? Get a little interesting. I'm gonna show you guys functions, and then I'm gonna go into learning it myself. Is that okay? Am I gonna get any complaints about that? So let's say what I'm gonna do is I'm going to write a function that doubles a number. I mean, that's really stupid. Fuck it, sure, let's do that. So we're gonna say 2 times 28 equals 17. So this line of code, we're gonna call a function called double with the number 28. We're gonna presumably double it and then return the result. So I'm gonna show you how to define functions. I mean, you might already have picked it up. So in Python, you would have typed in def to define a function. In Rust, you just type in fn, and then the name of your function, all that. So I'm defining my function. It's going to be called double, open and close parentheses, and inside the parentheses are going to be all the variables, curly braces, and that's good. And all my code is going to be in the curly braces. So now in Python, if I was making this, I would just type like x, and then I would type in return x times 2 or something like that, right? Well, actually, give me a second. I would type in that in Python, right? That's what I might type out. So, Jesus Christ. To make this work in Rust, we're going to have to make it a little different. So after x, we're going to have a colon, and we're going to specify the type of x. So I'm going to say x is going to be a 32-bit integer. And then since the expression, there's this expression, x times 2, is the last statement in the function, and it's the thing we're going to be returning, we actually need to remove this return statement. So it'd just be this. So it knows that since this expression, x times 2, is the last line in this function, and it's just that expression, that we must be returning that value, right? So what we're going to do, what I'm going to do is I'm going to say, I'm going to have, no. So we're going to run it as is, right? So it should, it should work pretty fine. Yeah. If I, oh, jeez, God, okay. Sorry. So the last thing you need to do with your function, if your function is actually going to be returning a value, you need to specify the type of the return value. Okay, so after your parentheses in your function declaration, you're going to have this arrow, so a minus sign followed by a right arrow or greater than sign, and then you're going to have the name, the type that will be returned. So in this case, the type that I'm going to be returning is a 32-bit integer, right? We're taking in a 32-bit integer, we're taking a number in, multiplying by 2, and just returning a number. So now we should be all good. And you can see down here, God damn it, I'm going to eat my lungs. Anyways, hopefully you can see it okay. 2 times 28 is 56. That's pretty sweet. And I mean, I can change this. So if I said 20, then I change that, it would be, and I run this, I should expect 40. And we get 40. Sweet. So it's working flawlessly. But so if let's do factorial. Because then I can talk about some other things. So we're going to define this recursively. So I have to change this to n because I want to, damn it. So the factorial function takes in a number, which is a 32-bit integer, and returns a number, right? So what we're going to do is we're going to have an if statement. If our number is equal to 0, or let's say less than or equal to 0, then we're going to return 1. Otherwise, if it's greater than 0, we're going to return n multiplied by the factorial of n minus 1. So this should run just like any other Python factorial, right? And I mean, I want to emphasize how similar this is in style to Python. Anyway, so let's run this. We should expect factorial of 5 equal to 120. So if I run this, I'm gonna actually, gosh, I'm so weird. Yeah. So I'm gonna have that, and then yeah. So you can see it shows here, it correctly calculated the result. The factorial of 5 is indeed 120. If I change this to factorial of 4, we should be expecting 24. If I run this once more, the factorial of 4 is 24, right? I mean, and I'll be honest with you, whenever I have tried to use compiled languages like C or C++, I can't, because those languages, they're just kind of gross. I don't know how else to describe it, because you have to say so much to do something, right? But in this, I don't know, it's like the Python of systems programming. And I'm really enjoying it. It's really nice to look at. Anyways, besides that, so that's pretty neat. Note here that I actually have to use the return statements because it's not some expression at the end of the function. I mean, if I wanted to, I guess I could remove this. I could delete this keyword. This should work just the same. Yeah, and honestly, that's a little nicer because the only time we're going to return this line is if n is greater than 0. Anyways, so that's cool. Yeah. Now that I've gotten that out of the way, I'm gonna work on learning it. I don't know how much longer I want to stay up for. I'll stay for a little while longer and then I'll end the stream. So let me get cracking. So what did I do? I did functions, string threads, variables, error handling. It's primitive types. Okay, I'll run through this. Oh, this is just booleans. That's I already know about those. I'm good. 2 characters. Oh, it's alphabetic. Is numeric. Huh. 3. Okay. I guess this will be good to see if I know how to have arrays. What's an array real quick? An array is a list that is fixed in length. Even though you could argue that the lists in Python are really arrays. Anyways, so I'm gonna have this be a gosh, ding dang darn it. So this is an array of 32-bit integers. And it is 10 items long. Yeah, I think that's how I do it. So if I said 1, 2, 3, 4, 5, this should say, Matt, I eat arrays like that for breakfast. Could I just do... No, come on. Okay. I read you. 10, 11, 12, 13. Could I actually, wait, give me a second. I want to, could I possibly just go, is this something I can do? Me no like. Let's look it up. Set rest set array to range. Da, da, da. Oh. I don't like that. I don't like it. I don't like it. Okay. Yank to the end of the line. Or yank in there. Two, 4, 6, 8, 10. Cool. Did I just do that? Yep. So now I'm on 4. Also, by the way, this is how anyone programs. They look stuff up. Okay. So if I did that and I went over here, snag that, boink, boink. I made this do something. 2, 3, 4. So sorry for index 1. 2, 1, 2, 3. Wow, I did it. Sweet. So it's number 4, 5. This is a tuple. Because this is just deconstruction like in Python. So it says a name and age as you go. This should compile. Yeah, you can't best me. I am an all-powerful god. Newen. Well, I mean, smarter people, more programming stuff, but that's besides the point. You can use tuple indexes to access second members. Okay. Second number is numbers 1. This should compile. And I need to plug in my computer, otherwise it will explode. Oh, woe is me. The devastation is unknown by the common man. Let's see. Oh, I forgot. Tuples are kind of weird in Rust. I use dot instead of brackets. Forgot about that. There we go. So 6, so 7. Oh, we're done. So standard library types. I don't want to do this. I'm good. Okay, I'm gonna go. Hopefully this was in some way fun or interesting. Yeah. If you want me to do more stuff with Rust or something, I guess just tell me somewhere. Yeah. Hope you learned a little bit. I would highly recommend learning Rust. It might be on Replit. Let me see. Yes. Again. Let's see. Rust. Here we go. Yeah. Looks like you can make Rust stuff. What? What is? Okay. Oh yeah, so you can do it right here, and you see the source code. But look, so you can play with Rust all on your browser. Cool. Yeah. Anyways, see ya. Hope you had fun. Yeah, I want to end it.